Assalamualaikum and hi everyone. I am Sir Akmal and in this video we're gonna learn about topic 6.5, the concentration of the aqueous solution. The learning that can be achieved from this video is 6.5.1.1, state the meaning of the concentration of the aqueous solution, and second, 6.5.2, solve the numerical problem involving the concentration of the solution. So first, we're going to take a look at the solution, which are a type of mixture that I use a lot in chemistry. We will look at the different kind of solution and see how they are made, and we will look at the general characteristic that all solutions have. So, to start off with, what is a solution? Solution is a homogeneous mixture between two or more substances. Homogeneous is an important word here, and it means that the parts are evenly distributed, and there is a uniform and even distribution throughout. Let's take a look at this. Let's say we mix a little drink mix in water and stir it around. The parts mix evenly, and we will get a homogeneous mixture or a solution. Take a look at this even distribution uniform solution. You can look at here, here, or here, and the parts will look the same as anywhere else in the solution. Everything is evenly distributed. The parts mix evenly. Okay? Now, to better understand this, we will do a comparison between something that is not a solution. So, we got our solution, our homogeneous mixture right here, and the part mix evenly and it is a uniform. Over here, we got our heterogeneous mixture where the part do not mix evenly. We have oil here and water here, and you can see a different part distantly. T is not uniform and even, and T is not a solution. Now, if you had a heterogeneous mixture like this here, you can shake it out, stir it up, and temporarily form a suspension which will look like this. Everything is kinda mixed up in there, but that is only temporarily. Eventually, everything is gonna settle back out or separate back out and end up like this again. So, the part will eventually separate out in the heterogeneous mixture. But on the other hand, the part in the solution will never separate out. They are just gonna stay mixed basically forever. So, there is solution versus not a solution. Now, let's start getting into the detail of the solution. First off, the parts. Every solution has two parts. Let's say we are dissolving sugar into water. The substance that we are dissolving in, we call that solute. Here, the sugar is the solute. The substance that the solute is dissolving in, we call that solvent. Here, water is the solvent. So, in other words, the solute dissolve in the solvent. You can see that right here. Now, the solution can have more than one solute, but can only have one solvent. For instance, let's say that we take some salt and dissolve some of that in this solution. The salt will become a solute along with the sugar, but the solvent still will be just the water. So, the solute will dissolve in the solvent. Now, to add a little bit more, the solvent is usually the substance that is present in the greatest amount, and the solute are what we have less of. But there are always an exception. Anyway, let's talk a little bit more about solute. So here, we have the solute that we have talked about so far. We got drink mix, we got sugar, we got salt, and we saw how to dissolve in the liquid, the water, to make a solution. These are all solid, but the solute don't exactly have to be a solid. We can make a solution by dissolving a liquid into another liquid, and we can also make a solution by dissolving gas into the liquid. Now, let's look at the example of some of this other solution. Here is an example where we make a solution by mixing two liquids. T is antifreeze, which is used in car to help cool down engine. Antifreeze is made by taking a propylene glycol, which is a thick, clear, viscous liquid, and mixing it with water. But sometimes there is a fluorescent dye in there. There is also a solute. As you'd expect, the liquid solution is homogeneous. It looks uniform and it does not separate or settle out over time. Now, you can also make a solution by dissolving gas into the liquid. If you dissolve a carbon dioxide into water, you can make a solver. Here, the gas is the solute and the liquid is the solvent. And if you add some flavoring or sugar, those are also solute but not in gas. You can make soda or pops. In this water, you can see that the solution is nice and uniform. Now, if you think about all the solutions that we have looked at so far, you can see that all of them are in liquid state. They are all liquid. We call this liquid solution. If your solvent is liquid, your final solution will also be in a liquid state, no matter what the solute is. If your solute is solid, liquid, or gas, if your solvent is still on liquid, the final solution will also be liquid. And going a step further here, we can see that all of our solutions have water as a solvent. That is not really unusual because water is the most common solvent in chemistry. Sometimes you will see other, but water is by far the most common. We have a special name for this solution. Aqueous solution, a solution where water is the solvent. You might know that aqua means water, and this is where the name aqueous comes from. Aqueous solutions are super common. They are all over your house. Most of the beverage are aqueous solution, and most of the solutions that we use in the chemistry lab are aqueous solution as well. They are really everywhere. So, just to review here, we have talked about liquid solution and aqueous solution have been the start, but not all the solutions are in the liquid state. There are also non-liquid solutions. These are not usually what we think of by thinking of solution and dissolving, but they are also important. So now, we will talk about solution of gases and solution of solid, which often are metal. So, we will start with some solution for the gases. Whenever we mix together gases, they usually blend together evenly. So, we usually form a solution or a homogeneous mixture. The most common solution of the gases is the one you breathe right now. Air is a solution or a homogeneous mixture. It is a mixture of the nitrogen, oxygen, and a bunch of other gas. So, how can we tell that air is a solution? If you take a sample of air in one place, which is right here, and compare it with another sample, which is taken close by, right here, you will see that the three samples have a uniform composition. That they contain the same proportion of gases and evenly distributed throughout each other. And also, gas in the air don't separate out over time. So, we need oxygen to breathe. We don't have to ever worry that one day the oxygen will separate and flow up into the sky. So, for air, the composition is even and the gases don't separate out over time. We're definitely talking about solution. And now, finally, there are also solutions made by mixing solid together. An alloy is a homogeneous mixture or solution of metal. Now, how will you dissolve a solid and mix them together? It's actually pretty cool. To make an alloy, you take two different kinds of metal, or sometimes more, and melting them and mix them together while they are still in molten. After they cool and solidify, the two metals will evenly spread throughout each other. But to your naked eye, it will look like one single metal, which is nice and uniform, which is a hallmark of a solution. People make alloy because they have a better property than a single individual metal. One of the first alloy that people make are bronze, which is a mixture of tin and copper. And steel is an alloy of metal and non-metal, which is iron and carbon. And most steel also contain other metal besides iron. The most important thing to remember here is that alloy is a homogeneous mixture or solution. The parts are evenly distributed and the alloy look uniform in the naked eyes. So, let's review what we talk about here. Solution is a homogeneous mixture made by dissolving a solute into a solvent. Because solution is a homogeneous mixture, the substances are evenly distributed and the solution has a uniform appearance. A liquid solution is in a liquid form made by dissolving a solid, liquid, or a gas into a liquid solvent. Most liquid solution that we talk about in chemistry is an aqueous solution, which means that the water is the solvent. But keep in mind that the solution can also be in mixture of gases or they can be in a mixture of solid like metal alloy. So that is the introduction to the solution. Now let us learn about the concentration of the aqueous solution. The concentration of a solution is a measure of number of particles of solute, which is a dissolvable solid in a solvent in which the solute is dissolved. What might you say about the number of particles found in a treated solution compared to a dilute solution? Take your time. The answer is the number of particles in a concentrated solution is greater than the number of particles found in a dilute solution. Think about when you sweeten a drink by adding a sugar into a tea. The more sugar you add, the sweeter the drink tastes. We can calculate this using a two formula and accompanying a formula triangle. The first way of calculating a concentration is by using a mole, the amount of chemical substance used, and divide it by its volume. Here is the formula triangle. Most of the time, the volume are measured in the cubic centimeter. So, 1000 cubic centimeter is equal to 1 decimeter cube, or in another word, 1 liter. So, how many deciliters are in 400 centimeter? Try to think. To get the answer, you must divide 400 cubic centimeter with 1000. So, 400 cubic centimeter is the same as 0.4 decimeter cube, or in another form, 0.4 liter. Did you get it right? You can find any of this quantity by covering the one you are looking for with your finger. For example, if you cover mole, you can find this by multiplying the concentration by the volume. This is because the two terms at the bottom of the triangle are always multiplied together. If you want to find the concentration, you cover this and divide the number of mole by the volume. Let us try this now. You have 3 mole of salt and dissolve it in 3 liters. Use the formula triangle to calculate the concentration of the salt solution. Don't forget the unit and try to think. 3 mole of salt divided by 3 liters of water is equal to 1 mole per decimeter cube of salt solution. Did you get it right, and did you include your unit? The second way of calculating the concentration is very similar, except sometimes we use a mass of substance divided by volume rather than mole of substance. The formula is the mass divided by volume and has a unit of decimeter cube rather than mole per decimeter cube. The formula triangle look like this. Let us try a challenge. If you know that you need 10 grams per decimeter cube of salt solution and have to dissolve it in the volume of 300 centimeter cube, what mass of salt that you should dissolve? Don't forget that you need to convert the volume from centimeter cube to decimeter cube. Try to think. The working is showing right now. Did you get it right? In summary, there are 2 ways of calculating the concentration of the solution. One involves the mole of the solute and the other the mass of the solute. The formula triangle can be used to find any quantity by covering up the one you need to find and using a multiplication or division as shown in the triangle. We have reached the end of the video. I hope that the content will help you in progressing your study. Until we meet again, I wish you good luck. Ciao.